My name's Hedley Apley, and in this session we'll take an in-depth look at the new features of Integrity Modeler 8.3 with some live demonstrations of the product in action. So we'll take a look at modeling for ThingWorx and the Internet of Things first, then move on to look at the new integration with Windchill, then briefly look at the Profile API, and then spend a bit more time on the web client. So starting with modeling for ThingWorx and IoT. There are two general areas that we focus on. Firstly, automatic code generation for both embedded devices and ThingWorx entities, and then secondly, simulation with ThingWorx in the loop to validate your system designs early on and your user interfaces. Lots of business value here: increased productivity by automatically generating code from your designs, and also improved quality by making sure that that code is consistent across all the different parts, and that the system parts will fit together. But also by simulating and modeling first, so that you can find problems earlier in the software development lifecycle. We cover many different levels of the architecture for ThingWorx and code generation. Down at the bottom we have very strong edge device code generation for languages such as Java and C++, generating code from the models, which is ThingWorx ready and ready to be deployed. In the middle we can design how those products connect together with their interfaces, and therefore generate the thing entities necessary for the connectivity. And at the top level of the architecture we can design the whole kind of user experience and the functionality expected, and also the context of the system, which leads nicely into the mashups and applications that need to be deployed for the control centers, for example. And we can automatically then from those models generate the code and the items that are needed for connectivity into the ThingWorx stack, which are then eventually deployed into the physical world. Automatic code generation is very simple. We've added a new ThingWorx profile which allows you to tag model items as ThingWorx items, so when we generate the code automatically, they're ThingWorx ready. You can then also generate all of the necessary connections automatically, so we automatically generate all the thing shapes and their properties into ThingWorx. You can then use those to build your mashups. So let's take a look at this in action. So here we are with Integrity Modeler, looking at our system design. This is a electric car charging system. It has requirements both for the driver and the car company, and those requirements are implemented in various functions, as in charging the car and using the charging station. We've also modeled some use cases and drilled down into detecting fraud when we're charging the car. For each of those use cases we really go into detail on the functions mapping, the requirements, the functions, and the structure of the sequence diagrams. So that's our high-level system design, and it maps directly onto our physical environment, the real world, with a car, a charging station, connection up to the cloud, and a control center. So we've designed our environment. We can also then drill down further and design the actual software that will run on the car and run on the charging station, and then automatically the connections between the two and the connections needed up to ThingWorx on the cloud. As well as the structure, we're modeling the functionality, the various states that both the charger and the car can go through. And from this level of information in our model we can generate 100% of the code. So this is just an example of the design of our software for the charger and the car. Once we've got to this stage and we've identified those items as ThingWorx items, we can automatically generate code using Integrity Modeler's ACS, Automatic Code Synchronizer. And here we're forcing the code to be generated from the model. As you change your model over time, the code will be updated automatically. So here we can see the generated code, and the ThingWorx items already generated automatically into that code. So it's ready to connect up to the ThingWorx cloud, and optionally to connect to other devices, other ThingWorx Edge devices. And here's the example of the Java code for the charger, which is also ThingWorx ready. So now that we have automatically generated that code, we can deploy it onto the charging stations and also into the cars, into the ECUs in the cars. The generation also generates the thing templates necessary to connect the charging station to the cloud and ultimately ThingWorx servers. We can now actually simulate the system. So using SciSim, we can simulate the connection of the car to the charging station. The code is run, or the simulation of the model is run, and checks that the car is a real car and that there's no fraud attempt. The car then can tell the charging station how much charge is already in the battery, and then we can go through the process of asking the user how much charge they want to add to their car. So this is SciSim running a visual simulation of the charging station. So this is all running off the model. The user can interact with the simulation, so a stakeholder can interact with the simulation, and here we're adding the number of units we want to charge the car, and we can start the car charging. So this is all Integrity Modeler SciSim simulating the charging. We can now see the charge running into the car, and that will then be logged by the device in the charging station and feed that information up to ThingWorx. So here we can see our mashup reading data, which is running actually in this case from the model simulation, showing our charging station, which is Boston 1, charging the car. So, as well as generating the software to run on the devices, we're also feeding information up through the internet to our ThingWorx cloud server to show the information on the dashboard. This also means that we can, the code that we've generated is also capable of running without that connection and talking from device to device. So if we lose the internet, we can carry on and safely disconnect the car, for example. Going back to the simulation, we're now completing the charging, and we're now ready to unplug the car. So we can complete the process, unplug the car, and our simulation based on the model and the automatic code generation is now complete. So that's a very simple example of generating code for ThingWorx and the Internet of Things from Integrity Modeler. We saw a brief view of the simulation for the interface of the charging station there in that example. Let's take a deeper look at simulating with ThingWorx in the loop. So with Integrity Modeler and functional simulation, as well as designing our system, and in this example it's an electric vehicle which can be driven with around streets using the gas pedals and braking as you'd expect. So we've designed our system in a model here. It has a battery, motors, powertrain, etc., and quite a detailed internal design. So here's the controller for our, and they call it a street scooter electric vehicle. As well as the thing itself, we're also designing the simulation. So these are the parts of the simulation co-simulating together. So we're designing our simulation as a model as well. Once we have that, we can then run the simulation, and this is Integrity Modeler's SciSim, running the simulation of this electric vehicle driving around the streets of New York City, showing how much energy is being dissipated and how much remains in the battery. It also shows the speed as we accelerate along the straights and brake and turn around the corners. And this is all based on the mathematical algorithms in the integrity model. So this simulation is all running off the model and the data that we have in that model. So we can see the vehicle slowing down, turning and speeding back up as it navigates around the streets. This route is a predefined test plan, so the simulation is running a simulated test against a planned route. And we can see here that the power is dissipating and the remaining charge in the battery is dropping as we're driving in this simulation. This is invaluable. I mean, it's one example. This is invaluable to stakeholders who want to see how the product is going to work, how the system is functioning before we create any physical prototypes. But as well as simulating using SciSim and that visual mockup, we can also send that data up through the cloud to ThingWorks, and this is now a ThingWorks mashup, a ThingWorks user interface, showing similar information, also a moving Google map showing the route around the streets, but also a much nicer graph of the power that's being dissipated and also the power remaining in the battery on the right hand side. So you can see the red line as we accelerate and brake, and the battery dropping in power as we use more power for driving around. So we can see expected range, we can identify any faults early on in this functional simulation of our model with ThingWorks in the loop, which will probably ultimately end up as the control system, the control interface for our system. As well as simulating our system model with the ThingWorks user interfaces in the loop, we can also take real-world data from our ThingWorks Edge devices and feed those into the simulation. So in this example, we'll take a deeper look at the same simulation of that electric vehicle, the street scooter, moving around, driving around the streets. Again, here is our design for that simulation, and we can co-simulate by adding other blocks into that simulation. And this time we're simulating with only the model in the loop. So here it's the same idea that we saw a moment ago. We can see the simulation feeding out. But now here's some real data that we've gathered from that car driving around real streets, and we can then compare that to our model-based simulation. And here you can see on the graph on the right hand side of our ThingWorks mashup that there's a difference between the actual power being used by the car as it drives around the streets. So there's either something wrong with our original system design, or maybe there's something wrong with the implementation of the car. Looking at the data more deeply, we found that we were skidding as we were accelerating away. We hadn't had any traction control in our system, so we've now added a traction control and limited the torque for the acceleration to 250. As we changed the model, the code was changed automatically if we're generating the code for the device, and now we can re-simulate using that new system design based on the real-world data, and we'll see that we have not only improved our simulation by finding those problems and using real-world data, but we've also improved our product, improved our system design by adding traction control and setting a limit to the torque. And you can now see that both the system simulation on the model and the real-world data match. So we've improved both our system design and also improved our product. So now that we've looked at Integrity Modeler, modeling for ThingWorks and the Internet of Things, now let's take a look at the new integration with Windchill. There are two parts to this integration. Firstly, productivity, so using the system model as a starting point for our bill of materials and part structure. And secondly, for bidirectional traceability, so that we can see the impact of change. Firstly, this increases productivity by giving us a flying start with our bill of materials part structures based on our system structures. It improves quality by avoiding retyping of information, but also finding problems much earlier during the system design phases, particularly if we're using simulation. It can also reduce cost by including product lines much earlier in the life cycle and getting more reuse and identification of variation. So let's take a look at productivity first and come back to traceability in a moment. On the productivity side, we're using the system structure but also the variability model to generate our configurable part structure and also our options and choices into Windchill PDM link. We do this by starting maybe with a block or alternatively a variation, running up a wizard that lets us then select which blocks and parts we're particularly interested in our system model. We can then from there drill down and choose the variations and variation points that we're interested in, export that information and then automatically import that into Windchill. Let's take a look at that in action. So starting with our model in Integrity Modeler, this is an example of a truck and a truck's powertrain. This is all useful design information at the system level with our system architecture and the various subparts of our system. And we can see that both on the diagrams in the database of Integrity Modeler. As well as this good useful system information, we also have good variability information about our system product lines in our parallel variability model. So here we can now see our variability in the diagram form. So this shows us the variability around transmission, about having automatic or stick shift transmission. And that's also useful information for our configurable parts in our bill of materials. So starting from the system model, we can then export to Windchill. We can choose which particular blocks and their parts we want to export. We can then see an automatically generated list of the variation points and variants that are linked to those model parts, and we could do it the other way around, starting with variation and deriving all the underlying parts and blocks. We can choose where to export the file. There's a configuration file that defines lots of the detail about how that's going to be generated. Generally you wouldn't change this or look at it, that would be hidden. So once we're ready, we can then automatically export all the information from the model. And as we export, there's a full log created, which we can keep for audit purposes and to check that everything went well. Now that we have our export, we can then import that into Windchill. This is an empty folder at the moment, and we can now import the file that we just created to gather the information from Integrity Modeler. So now we have the import complete. We have a first cut set of parts based on all the system information from Integrity Modeler. You can see the transmission types, the engine types, the powertrain, etc. As well as those configurable parts that were loaded in, we can also use the variability model information. So here if we create a new option set, and drill down into our information, let's make it a bit more visible. We can edit the filter, and in this case we'll take a look at the engine type, and you can see that we now have diesel or gasoline, and that came directly from the systems model, and then we can use that to filter our bill of materials and our parts. So a great lot of reuse that we're getting from our system model straight into PLM. As well as that productivity, we also need to be able to trace between our system model and our bill of materials. When we automatically created those parts using productivity, we could also at the same time create the trace links, but you may also want to create those trace links manually as things change, or where you have existing BOMs and existing system models. The traceability is created using the PTC Navigate Manage Traces app, which shows you model information on the left and bill of materials information on the right. But let's take a look at this in action in the tool itself. So we're starting here in Windchill, and we're having a quick look at a part structure which is currently not linked to any system structure. So here we have 4 parts. If you look at the Traces tab on the right, you'll see that they're not linked to anything in Integrity Modeler at the moment. From here we can start the PTC Navigate Manage Traces app. You'll see on the right the same 4 parts, and on the left we can now go to a Integrity Modeler server, and on that server we can look at a particular database, and inside that database we can look at any of the available models and their versions. We can also create bookmarks for those models and versions and jump straight to them as we have here, and then drill down inside that design and see our system structure. So here we have our street scooter grid, our electric vehicle, and all the internal design and blocks. We can select any of those blocks and then any of the Windchill parts, choose the type of trace, and when we apply, it will create the traces for us in the database to link those Integrity Modeler items across to those Windchill parts. So here we can see in the tab at the bottom the trace links on both sides, pointing from the model to Windchill and from Windchill to Modeler. Let's create a few more links so that we have something to look at later on in the demonstration. So here we're creating a link between one system block and 2 parts. It's creating those links both at the same time. So as you can see, there's a very quick and easy way to identify things you want to trace and link between and create those links. Now when we come back to Windchill, to the parts that we just linked, we can see in the Traces tab that we now have links to Integrity Modeler. It's showing the ID of the item inside the model, also the fact that it's a block with the icon there, and the more information like the version. But you can see the same trace links that we created a moment ago. Inside Windchill here we can also do things like delete the link if we don't want it. So this is a good place to clean up if those links are no longer valid. So let's take a deeper look. As well as the ID of the item and the icon of the item, we also have its version, which is inside Modeler. We can view more information, which we'll come back to later. We can see a detailed description, which server it's from, its title, its type, and the trace type. If we click on the view more information, it will now pop up the Integrity Modeler web interface directly on that model item. In this case it was a block with a full name of the subsystem, power subsystem inside our street scooter. As well as the properties and the information about the block, we can also see the diagram that it's represented on, and here's our powertrain, our power subsystem in our street scooter. PTC Navigate also has a view to see those trace links, so that we can hot link to either the rich client or the web interface that we saw a moment ago. Here we're now using the same type of link to jump to the Integrity Modeler full client, the rich client, and it'll go straight to the model item inside the Integrity Modeler. So here we have the chassis subsystem, and we can then see, for example, where it's been used and which diagrams that chassis is represented on, and then we can open those diagrams and see here the same diagram in the rich client and look at the operations that, for example, provided on that item. We can then carry on modeling just as we would be enhancing the design over time. You'll see in Integrity Modeler that it's recording those changes and who made those changes as we go, so it's a full transactional database behind the model. That's then automatically mark that link as suspect in Windchill, and then in Windchill we can decide after viewing the change whether or not we can clear that suspect flag and allow that to be a regular trace link again. As I said a moment ago, from PTC Navigate we can also jump straight to the Integrity Modeler web client, and here we're looking at the properties of that same chassis subsystem. And just to close, in the third point of navigating traces, we can also go to Integrity Modeler and see the links out from blocks to the parts that are actually over in Windchill. Click on the link and jump straight to Windchill and see the parts there. So we can view the trace links from Manage Traces app. We can also see them in Windchill, and we can also see them in Integrity Modeler. So you can navigate top down, bottom out, or middle out to see the trace links and the impact of change. So we've just looked at both the productivity workflow of creating first cut bill of material from our system architecture, and also bidirectional traceability, creating those links and then following and tracing those links from the new PTC Navigate Managed Traces app, from Windchill and from Integrity Modeler. Just to cover off the last two new features, we also added a profile API, which helps when importing profile specific model data. We also dramatically improved the web client for Integrity Modeler. So we've added more views. So in the past we could see properties and diagrams, but we've now added tables, matrices, text diagrams, decision sets and relationships. We've also added URL model references, which we saw a moment ago when we were navigating from the Trace app across to Integrity Modeler's web interface, for example, and to the rich client when we opened up Integrity Modeler on a particular block. We've added security, and all of this now runs on an underlying REST service. So this gives us real business value, making system models much more widely available inside an organization. They don't need to install Integrity Modeler, they can access those models directly through the web. Also improving quality by getting stakeholder buy-in and early review through this new web interface. So let's take a quick look at some of those items. Here we can see now a view of tables shown directly as HTML. We used to use Excel, that's no longer needed. Text diagrams are now also available in the web interface with all the rich text coming from the Integrity Modeler model. We can also show decision sets, so the variability modeling, variance, variation points, and the decision sets is now also visible in the web interface. As are relationships, so we saw some relationships when we saw which diagrams those particular blocks are represented on. All those types of relationships exist in Integrity Modeler in the models. So we can see, for example, which blocks implement which functions then link up to which use cases, and ultimately which requirements they implement. That all those types of trace links are already existing in Integrity Modeler. The rich client provides this relationship view, is now available also in the web client. So if you come to the Integrity Modeler web client from PTC Navigate, for example, and come in from Windchill to a block, you can now navigate from the block to the function, and then ultimately from that function up to the requirement. So we have full end-to-end traceability that we already had in the model, but now it's visible in the web interface as well. I mentioned a moment ago that we also provide URL navigation links. So there's a URL for every model item and every model diagram, which then you can share and include in diagrams, emails, other databases and tools. And when clicked on that URL, it will now automatically open either the Modeler Rich client or the web client directly on that model item or that diagram. We've also added authentication, so you have to log in by some process, including LDAP, into the web interface. This gives much more security, controlling access to the information. If you don't have an account, you can register using the interface and get up and running very quickly without requesting a login first. That authorization then applies all the underlying permissions inside Integrity Modeler's models. So we have access permissions, and those are then applied both in the rich client but also now in the web interface. So there's consistency and good control of access to models. And all of those features, all the web interface features, now run on the Integrity Modeler REST service. And this REST service is fully documented and can be used as an API by other people who are creating integrations with Integrity Modeler, but we use it ourselves as well. So that's a more detailed summary of the new features of Integrity Modeler 8.3. We looked at modeling for ThingWorx and IoT with some real examples of that running. We looked at the new integration of Integrity Modeler and Windchill, looking at both productivity and traceability, and then we briefly looked at the Profile API and the new web client functionality.